Hello students, welcome to this lecture number 2 on the structure of the atom. In the previous lecture we have discussed about the discovery of the electrons. Now in this lecture we are going to discuss, that is, the discovery of proton and neutrons. Proton, as we already know, that atom has one particles that is negatively charged. So it is very much necessary there must be a positively charged species. So what is there? There is a experiment done by the Goldsmith in the year 1886. Goldsmith found the positively charged ray when he experimented again in the cathode ray discharge tube. The cathode ray discharge tube, that in case of the cathode ray, when it is producing the cathode ray, now for this experiment he made some changes. We can call it is a modified cathode ray tube. This is a modified cathode ray tube. You can observe here that position of the cathode and anode has been changed. Here it is the anode. This is anode, you can see. This is anode. And here you can see this is the cathode, perforated cathode. To understand if there is any ray when the voltage difference is 10,000 volt, to perceive it, what we have done in case of in the cathode ray, same thing we have done. There is a coating of ZNS, zinc sulfate. So whenever any ray is producing due to this voltage difference and due to this particular condition, it will be easily be reflected here in the form of a light spot, the ZNS, that is called the phosphorence effect, fluorescence effect. Okay, so what Goldsmith found, when the voltage difference between these two has been made 10,000 volt, when it is made at 10,000 volt, and the pressure in the gas is 10 to the power minus 4 atmosphere. Pressure in the gas is 10 to the minus 4 atmosphere. What he observed, that there is a glow in this cathode ray tube, and here we have used the hydrogen gas. Hydrogen gas we have used, and there is a greenish type of color you can find. So at that time, what he found, that there is a flow of a ray from the anode to the perforated cathode, and this ray is called the anode ray. This ray is called the anode ray. This ray is called the anode ray. So why it is called anode ray? Because it is coming from the anode. But this ray has not been produced at the anode. It is produced somewhere else, that we will discuss later on. So this is anode ray. It is coming from the anode to the cathode, and it has been found that there is a greenish light. You can see the light of this effect normally depends on which type of gas you have used there. Okay. So this is anode ray, and sometimes it is called the canal rays. This is also called the canal rays. Canal ray Why this canal ray? Because it is going to the canal of the cathode. It is a part where it is the cathode and it is going to this. So this is also called the canal ray. And this ray, you can see what is the characteristics of this ray. Let us understand first. As we have discussed in case of cathode ray, characteristics of anode ray. Characteristics is anode ray is number first one, that it travels in a straight line. It travels in a straight line. It travels in a straight line. How do you say it travels in a straight line? Because if you put any object in the path of this cathode anode ray, what is going to happen? There is a sharp object. There is a sharp shadow of this object. Okay. So we can see it travels in a straight line. Number second point, that it is made up of material particle. Material particle means material particle. What it means? Because when we put some soft paddle, it will rotate this paddle. Means this is a particle having some momentum. That is why it is able to rotate it. Okay. So it is made up of material particle. Third point, that when we put some electric field in the path of this cathode ray, in this anode ray, what is going to find that it will deflect in the negative plate, negative charge plate. It will deflect on this. So this is because we know that positive will attract the negative, negative will attract the positive, and there is a repulsive force between the negative and negative. So it is the positively charged. So this is the third characteristics, the important characteristics. It is positively charged. Number 4 point, that you can see that it has the capability of ionizing the gas inside the gas. It has the capability of ionizing the gas. It has capability of ionizing the inside gas. But its capacity is more than the cathode ray. It can also penetrate a very thin metal sheet. It can also penetrate thin metal sheet. So this is a very important thing, but its penetration capability less than the cathode ray, but its ionization property is more than the cathode ray. And 6.8 reacts on the photographic plate. So these are the 6 characteristics. We will learn that it travels in the straight line, it is made of the material particle, it is positively charged, it has a capacity of ionizing the gas, it can also penetrate the thin metal sheet, and it reacts on the photographic plate. These are all those characteristics. Now we can see it is positively charged. Then, as we have done this exercise in case of cathode ray, if we do it, what we find that E by M, charge to mass ratio of this anode ray, is depend on the gas inside the gas. the hydrogen, if we take the hydrogen gas in the cathode ray tube, modified cathode ray tube, it will having the lowest E by M ratio compared to the others. Means the E by M ratio depend on the gas and also to the electrode. So let us calculate what is the E by M ratio for this hydrogen gas. Then we will conclude, we will understand something on this. The E by M ratio for hydrogen is 9.58 into 10 to the power 7 Coulomb per kilo. So we know already the charge is equal to 116 into 10 to the power minus 19. Now we put this value here, we can find out the mass of the hydrogen ion. Mass of the hydrogen ion is basically, we can find out 1.67 into 10 to the power minus 27 kilo. And this is basically hydrogen ion, means this is basically a proton. The mass of the proton is 1.67 and its charge is 1.9 into 10 to the 1.6 into 10 to the power minus 19. So this is a basically proton and it is a very fundamental particles of the gas. But if we use the other gas, there the E by M ratio will be different and it will be as per the multiples of their according to the gas having the mass. So this is a, we can say this is a proton, and proton having the charge of 1.6 into 10 to the minus 19 and its mass is 1.67 into 10 to the minus 27. Now we can understand what is the origin of this anode ray. It is called the anode ray, but it is not originating from the anode. It originates in the inside, from the inside the gas. What is going to happen? There is a ionization of the inside gas. The electron has been removed from these gases, so it will become a positively charged, and this positively cannon ray, or sometimes it is called the positive ray. So we understand here the discovery of the proton. Proton is again a fundamental particles of a atom, and it is for different atoms you will have its multiples, integral multiples of this value, and its mass is almost equal to the mass of the hydrogen atom. So that is the discovery of the proton. Now in the 1932, in the year 1932, Chadwick invented the ray. This is the by bombarding the high speed alpha rays with the beryllium, and this reaction of this like this is beryllium, this is mass number, and 4 plus alpha ray is basically the helium nucleus, and it is going to produce carbon, and so by bombarding the thin plate of beryllium, Chadwick able to produce one ray, one particle. You have to able to recognize one particle that is called the neutron, and this neutron have the slightly higher mass but it is having no charge. But with this reaction, beryllium when reacted, beryllium when high speed helium has been heated with the beryllium thin plate, and it is going to produce a ray which is called the neutrons. In the 1932 scientists discovered it. So that is all the discovery of the subatomic particles, that is electron, proton and neutron. Now we make a general chart of this, how that looks like, what is the properties and what is the characteristics of this. This is a chart we can try to understand that subatomic particle is electron. This is electron and its symbol is we are giving, that is E. Its absolute charge is minus 1.6 in 10 to the power minus 19, and its relative charge is minus 1, and its mass is 1.9 into 10 to the power minus 31 kilo. The mass is given here in kilo, and unified mass is given by 0.00054, and its approximate weight is 0. So electrons weight we can consider as a negligible 0. Then this proton. Proton symbol is P, and its charge is absolute charge 1.6 in 10 to the power minus 19, and its relative charge is 1 plus 1, and its mass is 1.67 into 10 to the power minus 27, and its unified mass is 1.007, and its approximate value is taken as 1. And another, that is your neutron. Neutron is symbol is A, and it has no charge and it has no relative charge because they do not have any charge. Then its mass is slightly higher than your 4, slightly higher than the proton, and that is 1.008. So this is a chart. This chart will be helpful to solve any type of problem. So electron symbol is E, is absolute charge. AB means absolute charge is minus 1.6 into minus 19, and relative charge minus 1, and mass is 9.1 into minus 31 kilo, and its unified mass is 0.03054, and here the proton is like this and neutron is like this. So that is all for the discovery of the subatomic particles. We discover, now we are understand how the other particles has been discovered, that is proton and neutron. And that is all for today's video. Thank you very much for listening. If you like this video, you can share to your friends, and that is all for today's. Thank you very much.